Hello students, yesterday we discussed one problem on the Helmholtz resonator where I used the flanged one. Now as I mentioned yesterday, I'll give you two more problems, okay, might be flanged, unflanged, whatever, which as an assignment which you can submit by 15th of November. Fine. Now the last topic in the second module is basically muffler. Okay, now everybody has driven a two-wheeler or a four-wheeler or any vehicle as such. Okay, they're aware of the term what they mean by muffler. So what is muffler basically? Muffler is basically a device for reducing the amount of noise, okay, emitted by the exhaust of an internal combustion engine. Okay, so on a two-wheeler or a four-wheeler you have seen a silencer or a muffler, okay, which is actually defined as a section of a pipe or a duct which has been shaped. Okay, if you see sedan class cars, they have a little different shape of the silencer compared to the normal two-wheelers or other normal cars, I should say. They are differently and specifically shaped in such a way that they'll really look elegant. So what is their basic job? Their job is to reduce the transmission of sound while allowing the free flow. Okay, so for us in acoustics, why it is important? Because again the sound is concerned. Clear? Now as far as practicals are concerned, this is actually a practical what you have. Okay, so I'll explain to you how you study the muffler or a silencer in laboratory. So in the laboratory we have this particularly made pipe. Okay, so in the lab I will be able to show you next lecture. You have such type of pipe. Okay, so this type, because of this particular shape, okay, this is called as the expansion chamber muffler. This inlet and outlet has got the same dimensions, but this part is little expanded. That's the reason the name is expansion chamber muffler. Now how the practical is done or what you measure in this practical, you basically measure what is called as the transmission loss. Okay, now for this what all you need? You need basically the audio frequency oscillator which is connected to this horn driver unit. Okay, now horn driver unit will fit properly, okay, at the inlet. This is the inlet pipe, so you need to place the horn driver unit over here like I showed it over here. Okay, and horn driver unit will not do anything on its own until and unless you put a audio frequency oscillator to that. Okay, then only it will be able to generate sound which will pass through this muffler or a silencer. Okay, so as I mentioned the frequency, so you have the frequency set on this audio frequency oscillator ranging from 100 Hertz, 130, 160, 190 and so on till 310 Hertz. Clear? Input job is done. Now as over here you will be able to hear the sound very clearly. Then the next job is, this is the one more inlet, it is mentioned, made properly specifically to insert the SPL meter, that is the sound pressure level meter, to measure the SPL value. Okay, what are the observation? Input SPL reading, output SPL reading. Input is over here, output is over here obviously. Okay, so this is my S1 cross-sectional area, this is S2 cross-sectional area, this is the length of the muffler. Okay, the sound wave is passing through this inlet, then it will pass through the expansion chamber and then again it will be over here. So what is my job? I need to get transmission loss. For that I need to know, I had to use this formula, 10 log m minus 1 upon m square sine square kl tb. Now how you get this is not in our syllabus, so we will not break our head how this formula has come. But transmission loss you can read more on the net, not an issue at all. Clear? So our job is to measure this m and need to know what is this KL. Out of this KL, L is length, that is understood. Okay, so when we are taking the reading at input, what you should do, you should close the output with a bushing, rubber bushing. Close it, by which the sound will not pass through this. And vice versa, when you take the reading at the output over here, that time this has to be closed properly. This is the alternate. So when the suppose 100 hertz frequency is set in the audio frequency oscillator, your job, you want to measure input, okay, input at the inlet pipe, then this has to be closed. Take the reading on the SPL, write the reading over here. When you are taking reading over here, this has to be closed. Okay, so this is the way you will try and take the input output observation. Fine. Afterwards, what is your next job? Next job is lambda. Lambda is wavelength C by F. Now F you know, but the value will change everywhere because C is fixed but F is varying. So lambda will vary obviously. Now what is C? Velocity of sound, which is 343 meters per second. Done. Then KL. Now what is K? K is again 2 pi by lambda, propagation that earlier we mentioned. Okay. So K you know 2 pi by lambda, lambda you know, substitute the value, multiply by K and get this table. Then do sine square KL. Sine of KL, okay, you need sine square KL. Substitute the value over here. Now comes M. Now what is M basically? M is basically S2 upon S1. But what is S2? S2 is the cross-sectional area. Okay, cross-sectional area, and S1 is cross-sectional area. So how will I get this value of cross-sectional area? Take a thread and turn it around on this expansion chamber, okay, by which you'll be able to measure the circumference. Same way over here also. So either you take that ratio of 2 pi R2 by 2 pi R1, okay, or convert that and then get radius. Okay, so anyway this will be okay. So once you get a circumference, okay, you know how to get the radius also. Okay, so suppose my cross-sectional area is pi R2 square and upon pi R1 square. So either circumference you can, that way you can measure, or area wise you can measure. So once you get R2 by R1 bracket square, this is nothing but 2 pi R2 by 2 pi R1 bracket square. So this way also you can be, as I mentioned, the circumference, this formula also can be used. 2 pi R2 by 2 pi R1. Understood? So once 2 pi gets cancelled, R2 by R1. So you know very well the value of R2 square by R1 square is M. So put the value of M over here. Work it out for every value. So you will know the TL for frequency ranging from 100 Hertz till 310 Hertz. Okay. Then what is the next job? Next job is to plot the graph. What graph will plot? We'll plot the graph of TL versus KL. Okay. So as the KL is going to change, you will get a graph something like this. Okay. And at this point, you need to check when you get the highest transmission loss. So for this value correspondingly, what you have over here, you know KL. Once you know KL, it is easy for you to check the corresponding value of frequency. So the value usually comes around 180 Hertz. So at 180 Hertz, you could get the highest transmission loss. So this should be highest KL, but the highest KL, I have to see the corresponding value of frequency. This is the way you need to get the value of transmission loss for a expansion chamber muffler. This was your last topic of the second module. Okay. Now my job is to give you 2 problems as an assignment, which you can submit by 15th of November, as I mentioned. I know I have announced a test on today's date, okay, but I will take it later because I want the test was announced only for the reason that you will keep in touch, you will study something, otherwise you will be completely blank. Okay, complete the assignment and keep studying. I will take the test around 26th of next month. Clear? Thank you very much.